Good morning, students. Warmly welcome to Adarsh Vidyalaya Educational Institutions and the youth. It's my pleasure to all see in the online classes. So now we see the topic for gases. In a last class we discussed the fundamental laws of gases. Now we discuss the gases. So the gases are classified into two types. One is the real gases and another one is the ideal gases. So what is mean by real gas? The real gas is means if the molecules or atoms of gas interact with each other with a definite amount of intermolecular or interatomic force of attractions, then the gas are said to be a real gases. When the to interact, the atoms or interact with the other atoms, that means intermolecular or interatomics, that force of attraction is called as real gases. At a very high temperature or low pressure, a real gases behaves an ideal gases because in these conditions there is no interatomic or intermolecular force of attractions at the times. So when a high temperature of low pressure, the real gases behaves an ideal gas because in these conditions there is no interatomic or intermolecular force of attractions. And then what is an example of real gases? The any gas that exists a real gases: nitrogen, oxygen, carbon dioxide, carbon monoxide, helium, etc. Because the real gases have small attractive and repulsive force between particles, and ideal gas do not have attractive and repulsive force. The real gas particles have a volume and the ideal gas particles do not have a volume. Now we discuss the ideal gases. If the atoms and molecules of a gas do not interact with each other, then the gas is said to be an ideal or a perfect gas. So the atoms or molecules does not interact with the another atoms or molecules. That gases are called as a ideal or perfect gases. Actually, in a practice, no gas in ideal. The molecules of any gas will have a certain amount of interactions among them, but these interactions are weaker when the pressure is low or the temperature is high because the interatomic or intermolecular force of attractions are weak in ideal gas. Hence, a real gas at low pressure or high temperature can be termed as a perfect gas. In ideal gases obey Boyle's law, Charles' law, and then Avogadro's law. All these laws state the relations between various properties of gas such as pressure, volume, temperature, and number of atoms. In a given state of the gas, all these parameters will have a definite set of values. When there is a change in the state of the gas, any one or more of this parameter change its values. The above said laws relate these changes. So now we discuss the ideal gas equations. The ideal gas equations in a equation which relates all the properties of an ideal gas. An ideal gas obeys Charles' law, Boyle's law, and then Avogadro's law. So once again repeat, when an equation which relates all the properties of an ideal gas. So ideal gas obeys three laws. What is it? Boyle's law, Charles' law, and Avogadro's law. First one, according to the Boyle's law, PV is equal to constant. So already we discussed in the last class in a fundamental laws of gas. So according to the Boyle's law, PV is equal to constant. And the next second one, Charles' law. Charles' law, it means V by T is equal to constant. V by T is equal to constant. That means V is directly proportional to T. And then according to next third one is Avogadro's law. Avogadro's law means V by N is equal to constant. That means the volume divided by number of atoms or molecules equal to constant. So after combining three equations if we get the equations, following equation, PV is equal to PV divided by NT is equal to constant. So that's why V is a common, so that's why PV is equal to divided by NT is equal to constant. The above relation is called as a combined law of gases. The above relation is called as combined law of gases. If we consider a gas which contains mu, that means the number moles of the gases, the number of atoms contained will be equal to mu. That means N is equal to mu. The times of Avogadro number, that means Na. Also the Na means for the Avogadro number. So already we discussed the Avogadro number 6.02 3 to the power of 23 moles. So N is equal to mu Na. Mu is mole of gases, 1 mole of gases. That means 1 mole of gases into Avogadro number. Using these equations 5, in 4 can be written as a PV is equal to mu Na. That means N is equal to mu Na. So we should write PV divided by mu Na into T is equal to constant. So we put a constant values. The value of the constant in the above equations is taken to be Kb. Kb means for Boltzmann constant. Boltzmann, which is called as a Boltzmann constant. The value is 1.38 into 10 to the power of minus 3 joule per Kelvin. Joule per Kelvin. This is the constant value of Boltzmann. So we should write a constant is equal to Kb. Hence we have the following equation: PV divided by mu Na T is equal to Kb. So we move the dividing system. So PV divided by mu Na T. So it moves to mu Na T into right hand side. So PV is equal to mu Na Kb into T. So here mu Na Kb is also the universal law of constant. That means R. Here mu Na Kb is equal to R. The terms the universal gas constants. That means K 8.31 joule per mole Kelvin. That means the universal constant. So we should write a denoted as R. Mu Na Kb is equal to R, which termed as universal gas constant, whose value is 8.31 joule per mole Kelvin. So we should write a PV is equal to R into T. So R into PV is equal to R into T. The ideal gas equations is also called as the equation of state. The ideal gas equations is also called as equation of state because it gives the relation between the state variable and it is used as to describe the state of any gas. So once more, which gas is ideal gas? Which gas, sir? I have no doubt. Which gas are all the ideal gas? So I should it most usual conditions. For instance, at a standard temperature and pressure, most real gas behave qualitatively like an ideal gas. Many gases such as nitrogen, oxygen, hydrogen, noble gases, and some heavier gases like carbon dioxide can be treated like ideal gases within reasonable tolerance. And the next one, we should complete the lessons hereafter to remember the points. So some of the important points, we remember the important points in this lessons. So first one, the SI unit of heat energy absorbed or evolved, joule, is called as a joule. The SI unit of heat energy is joule. The heat always flows from a system at high temperature at a low temperature. Heat always flows from high temperature to low temperature. Temperature is defined as the degree of hotness of a body. Temperature is degree of hotness of a body. And the SI unit of temperature is Kelvin. The SI unit of temperature is Kelvin. And the next one, all the substance will undergo one or more of the following changes when heated. When heat the substance, it will be undergo one or more changes. So what is that? Temperature of a substance rises and substance may change state from solid to liquid or a gas. The substance will expand when heated. And the next point, all forms of matter, that means solid, liquid and gas, undergoes expansion on heating. And next one, for a given rise in temperature, a liquid will more expansion than a solid and a gaseous substance that the highest expansion than the other two. The next one, for a given heat energy, the real expansion is always more than that of apparent expansion. For a given heat energy, the real expansion is always more than that of apparent expansion. If a liquid is heated directly without using any container, then the expansion that you observed in terms of real expansion. So, if the liquid is heated directly without using any container, that means the real expansion. The expansion of liquid apparently observed without considering the expansion of the container is called as apparent expansion of liquid. And the next one, if the atoms and molecules of gas do not interact with each other, then the gas is said to be an ideal gas or a perfect gas. The atoms and molecules do not interact with each other, then the gas is said to be ideal or a perfect gas. The ideal gas equation is also called as equation of state is PV is equal to RT. That means pressure into volume is equal to universal gas constant into temperature. So here R is known as the universal gas constant. The value is 8.31 joule per Kelvin, mole per Kelvin. So thanks for watching. So don't skip the videos. So thanks for watching. In the next class we discuss formulas and then problems. Thank you.